Alright, let's look at this example here. Evaluate the limits, right? So as you know that this case, so we can try to look at what type of limits is this. So we put 2 here, 2 minus 2, 2 minus 2. So on top you put 2 square minus 4, right? You are getting 2 square minus 4, you're getting 0. 2 minus 2, you're getting 0. This is not supposed to happen. This is undefined, right? This is undefined. It's not true in mathematics, you know, right? It's not true in mathematics because this is no limits. This is direct substitution. You put the value 2. It's exactly 2. Means that the x is equals to. Then this function is undefined when x is equals to. But the function has a value when the x is not 2 but near to 2. Do you understand what I mean? So it means that x equals to 2, this function is undefined. Equal is undefined. But near to 2, yes, this function is having a values. Alright? It's not defined, but it's having a values. So then you look at this. So as you know that this one limits as x approaching 2. The case here will be, if you direct substitute, this is the case. The case of 0, 0. So case of 0, 0, in the previous video, the concept I talked about factorization. Factorize first, eliminate the common factor. For example, this one, x squared minus 4, can be factorized into x minus 2, x plus 2, right? So over with x minus 2 here. So then you have a common factor. There is a common factor. So as you eliminate this common factor, you can evaluate the limits of this function. So it means that x plus, if you can substitute the 2 inside here, or you can rewrite this as x approaching 2. After you eliminate this 2, you have x plus 2. Then now you can directly substitute. 2 plus 2 equals to 4. Means that the limits when x approaching 2, this is the value. Alright? But when x equals to 2, there are no value, undefined, right? Undefined. So we study what happened when x approaching 2. Yes, there is a value, but not when x equals to 2. Alright? So this is a technique that I apply here. So let's move on to the next example. Alright, let's continue with this example. So, okay. As I tell you that if you want to evaluate a limit, at first, you must directly substitute the value into the function first as a test, alright, as a test. So it means that as a test here, we have negative 1, right? We substitute negative 1 minus 3, negative 1 plus 1. So if you calculate, you will have 4 minus, you are getting 0 over 0. This is not okay, right? This is the case. This is the case of, this is not okay. Because if you directly substitute, you're getting 0 over 0, which is undefined, right? This is the case here, 0 over 0. If this is the case, you're using the method of factorization, right? Factorization. So you factor out the common factor. You factor out the common factor. So of course, this is a quadratic that you need to factor. So you have 4x3, x1 plus minus, right? So if you see 4x squared plus x minus 3, right? So this is the common factor here, right? It's a common factor here. After we eliminate this common factor, then we can evaluate the limits of this function. Means the value of this function when x approaching negative 1. So you will have limits x approaching negative 1 of 4x minus 3. So you can directly substitute now into the function, which is 4 negative 1 minus 3. So you are getting negative 7, right? Negative 7. So again, I remind you again, right? This is for concept, for concepts. So it means that if you directly substitute, f negative 1 is undefined. f negative 1 is undefined. If you directly substitute, this one is undefined. But when you find the limits, when you find the limits, so when you find the limit x squared plus x minus 3 over x plus 2, there is a value, negative 7. So when x approaching negative 1, there is a value. When x equals to negative 1, this is undefined, right? It's undefined. So that's why we need the limits to know that what happened to this function when it's very near to negative 1 here. So, okay. So this is the way you evaluate by factorization. Okay, we will go for another example, which will be more powerful. Alright, let's look at these examples. So, what happened when x approaching 1 is not x equals to 1, but we must have a test before you evaluate, right? We must have a test here. So you can put you testing, right? You're testing the limits here. So you know that 1 cube minus 3 1 square. You direct substitute first. Okay, but I never put limit here. Limit here. I just direct substitute here. So plus 5 times 1 minus 3. Yes, what is it? Right? If you put 1, negative 2, negative 3, negative 5, 0, right? So if you put 1 square minus 1, you're getting 0 also, right? So you're getting 0 and 0. How come 0 over 0, right? So means that 1 cube minus 3 1 square plus 5 times 1 minus 3 over with 1 square minus 1 is that undefined, right? It's undefined. Because why? The case of 0 over 0, right? Which is not true, right? So, but when you substitute a value very near to 1, the concept here again, very near to 1, so it's not equal to 1. This one you substitute x equals to 1. This one I said x near to 1. What happened? X near to 1 can be 0.999. Or it can be x equals to 1.000001, right? Any value that very near to 1. Very near. I said very near. Very. Okay? Very near. Cannot be 2. Cannot be 0. Very near to 1. What will happen to this function here, right? So when we're very near to 1, it's not 1. It's not 1, very near to 1. So it's not 0 over 0. If you consider it's not, if you put a value that very near to 1, it's not 0 over 0. Alright? So if this type of case here, we have value. It's defined. Alright? It's defined. So it's have value. So now limit as x approaching 1. So as you know that when you put 1 here, you're getting 0, right? You put 1 here, you're also getting 0. Okay, so this is a cubic function, right? This is a cubic function. So as you learn in chapter the polynomials, the concept of polynomial, if you put where the value x equals to 1, right? If you put that x equals to 1 inside here, you're getting 0, means that 1 is a 0, right? 1 is a 0. So 1 is the 0 of this polynomial. So how should I evaluate this, right? So, okay, I erase this one. So 1 is a 0. So means that if you put 1 here, you're getting 0. So means automatically that 3x squared plus 5x minus 3 is equals to x minus 1 is a factor, right? Because you substitute 1, you're getting 0. So x minus 1 is your factor. Then you will have your another 2 factors, so which is ax squared plus bx plus c. A quadratic multiplied with a linear factor, you're getting a cubic function here. So what is the value of a, right? As you know that a multiply 1, right? 1 here. So you're getting equals to 1, right? X cubed. So you compare, here is 1, right? You're getting 1. So a is 1. Then we look at the constant term. How to get the constant term? Is negative 1 multiplied with c. Negative 1 multiplied with c, we have negative 3. So c equals to 3, right? Then you have c equals to 3. So now if I rewrite x cubed minus 3x squared plus 5x minus 3 is equals to x minus 1. Your a, you know, is 1, which is x squared. Your b is, you don't know the b, but you know the c. The c is 3, right? The c is 3. So now, later, I want to find the b here. I can, using this one, right? Just now, I'm using 2, now I'm using 3, or 4 also can. So, comparing the coefficient of x squared, right? Comparing the coefficient of x squared, right? So, it's negative 3 here. The coefficient for x squared is negative 3. So, what is the coefficient for x squared here? X cubed. Not related. Bx squared, yes, b, right? Bx squared. 3x, negative 1x squared, yes, negative 1, right? So the rest will be x and constant. So the b will be negative 3 plus 1, which gives you negative 2, right? You are getting negative 2 here. So now you know that. Therefore, you know that x cubed minus 3x squared plus 5x minus 3 can rewrite as x minus 1, ax squared, a is 1, x squared, b is 2, negative 2, right? Negative 2x plus with c. c is 3. So if I factorize, I will getting x minus 1. Alright, I think that's all. Alright, I don't want to factorize completely because I can see x minus 1 here. I think limits, okay, finally, therefore, limit as x approaching 1 for x cubed minus 3x squared plus 5x minus 3 over with x squared minus 1 for this one, I can rewrite as this whole thing, I can rewrite as x minus 1, x squared minus 2x plus 3, right? Over with, okay, you can factorize this if you want. So, but you look at this one, x squared minus 1, right? X squared minus 1, you can factorize become x minus 1, x plus 1, right? X minus 1, x plus 1. So, this is the common factor that you want to eliminate. After eliminate, then you can getting the value here. So, you have 1 square minus 2 times 1 plus 3 over with 1 plus 1. Then you have negative 2 here, negative 2 plus 3, you have 1, 1 plus 1 you have 2. So means the answer for this one is 1 over 2. When x approaching 1, the answer will be approaching 2. So I will teach you a way of evaluate a limit by using calculator here. Okay, this is special for you. So you key in this function. So alphabet x. Okay, you can key it alphabet x cube. Sorry, alphabet x. Right, alphabet x. So shift cube. Right, cube. Minus with 3 alphabet. Can I see that here? On top here, there is an x, right? There is an x here. So x x cubed square, alright, square, so plus 5x plus 5 alphabet, right, this one, you see there is an x here, so x, so minus 3, so then you have alphabet x square minus 1. This is the function that you get here, alright, can you see that? So it will be x square minus 3, x cubed minus 3x squared plus 5x minus 3 over x squared minus 1. So you're pressing the button, calculate, right? Calculate. So choosing a value very near to 1. What is very near to 1? You can choosing value 0.99999, right? Very near to 1. Once you round off, you're getting 1. Okay, then you're pressing equal 2 times. So you are getting a value near to 1, right? Oh, sorry. This one is 1 square. 1 square minus 2 times 1, you have negative 1. Okay, this one I calculate wrongly. It's supposed to be, that's why we need calculator, right? We can using calculator to evaluate. So this one is negative 1 plus 3. You have 2 over 2, which give you 1. The value should be 1, sorry. So the value here should be 1. You see, with the calculator, I can check my answer. It's near to 1, right? It's near to 1. So if I want more exact, I calculate 0. Even more 9 here. Just now I'm pressing 5, 9, right? So now I'm adding more 9. Means the nearer to 1, the better the approximation. Right? Equal again. You see, I'm getting 1, right? I can calculate I can calculate 1.0001. Okay, try to think. 1.001 is very near to 1, right? You're pressing equal. Now you are getting the answer 1 also. Exactly the same here. So means that you can using this calculator to evaluate the limits. So that's all for this video. I will give you 3 more examples about the concept of 0 divided by 0.